quiet, mid-century living room, a pristine household where everything has its place, right until a young boy decides to look under the hood of these interlocking metal teeth. He targets clocks specifically, prying open the casing to hunt down the exact mechanisms that keep time ticking forward. Naturally, his mother sees a mess. She sees a ruined clock and a frustrating habit of breaking perfectly good household items. But he isn't breaking things for the sake of destruction. When he rips the back off a family radio, he's attempting to map how invisible music travels through this exact array of glass vacuum tubes and copper wiring. Stripping away the wood and plastic is the easy part. The real challenge is the transition from disassembly to reconstruction, figuring out how to reintegrate that mess of components into a working system again. This process of dismantling is how he audits his world. You cannot comprehend how machines function until you've seen the raw, unvarnished anatomy of their parts. The quiet routine of dismantling toys abruptly stops when a violent storm rolls in. Lightning flashes, the power grid fails, and the house is plunged into absolute darkness. The immediate adult response is to light a wax candle, but to an analytical mind, a candle is a flawed technology. It relies entirely on a finite resource that melts away and eventually dies. Watching the flame reflect in his glasses, the boy comes up with a permanent fix. He decides to build an electric light source that will theoretically never burn out. He is committing to engineering a continuous power system using absolutely zero budget, no formal laboratory, and a very limited grasp of actual electrical physics. Sudden deprivation forces a choice. Without a crisis cutting off the electricity, he might have stayed a passive observer. Instead, the blackout forces him into active innovation. He starts scavenging through his pile of dismantled junk. A rusty battery, a salvaged wire, a broken torch bulb, and a hollowed-out plastic bottle suddenly become the vital components of a completely new system. This animated schematic shows a closed-loop electrical circuit, tracing current from the battery through the wire into the bulb. A misplaced wire causes a short circuit and a spark. By rerouting the physical connection, the loop securely closes, allowing current to travel safely. On his bedroom floor, the physical circuit sparks to life. A brilliant neon blue-green glow ignites inside the plastic bottle, completely banishing the darkness. True scientific breakthroughs rarely arrive as sudden strokes of magic. They are the calculated result of failing repeatedly and tweaking the design using whatever discarded materials are lying on the floor. His mother walks in, expecting another pile of ruined household items. Instead, she finds a functioning, permanent solution to the blackout, realizing his relentless curiosity actually serves a practical purpose. This little glowing bottle is an engineered victory over environmental darkness. Now, take that same drive to understand how a small light works and scale it up to the size of a glowing spiral galaxy. The analytical framework doesn't change. The boy who methodically tested rusty batteries and broken glass eventually applied that exact same logic to map the physics of black holes and the origins of time itself. That boy was Stephen Hawking. As a degenerative disease stripped his physical ability to move, his mind remained boundless, generating new light for humanity. Producing internal light in the face of external darkness provides a way to see what is otherwise hidden. It suggests that even the most massive cosmic mysteries are eventually settled within the small space of a single.